All right, in this video, we're going to cover conditional statements, or basically if-else statements. So we're going to be testing to see whether or not something is true or false, and if it is true, then it's going to execute a certain block of code. If it's false, it's going to execute a different block of code. All right, so what I want you to do is create a new Windows Form application, call it Lesson 8, create a button called Do Stuff, and then a text box, which is going to show the basically be inputs that we can enter in. Create a label that is results, so that way we can show the results of pressing the Do Stuff button. And again, remember when you create this, I'm having you do this stuff over and over again, just as basically so it becomes muscle memory. So when you make the button, make sure you name it here in the properties at the lower right. So here I changed the name to button_do stuff. The text box is text_inputs, and then the label is label_results. And again, for the controls, you have button here, then you have label, and then we have text box that essentially we used here from the controls on the left-hand side toolbox. All right, now once you have that done, go ahead and pause the video, and once you have that done, we'll go ahead and execute the code. All right, so once you've got your form all set up and your UI created, what you're going to do is you're going to double click on the Do Stuff. That again creates an event handler here and a block of code for us to execute when the Do Stuff button is pressed by the user. All right, now in this particular case, we're going to have a Boolean data type or statement. Okay, so Boolean always returns true or false. So I'm just going to say, is this true? And I'm going to say it's false. It's not equal to true by default. If I wanted it to be default to true, then I could put in true and then put semicolon at the end. That's essentially declaring a Boolean type variable, and the values can be either true or false. Now, the way that if statements work is it's basically saying if is the first keyword that you have to put, then you have parentheses here, which inside the parentheses is going to be our conditional statement. And what conditional statement means is we're comparing two things, or we're trying to do a statement where we're checking to see whether something returns true or false. Then if it is true, then we're going to execute a block of code. So we have an open curly bracket and a closed curly bracket. And if the conditional statement is true, it's going to execute this code. So I'll just even put a comment here. If true, executes this code. Now, what we can also do is we can put an else statement. Now, the else statement is optional. So basically what we're saying here is that if this statement is true, it will execute the code. If I wanted to execute some code, if it's false, then I can also come in here and say, if not true, or basically false, or if any of the statements above are not true, then execute this statement or execute this code. All right, so how can we do some comparisons? Well, let's actually take the text box where we have here of inputs, and let's get with the user input here, and let's see if it's equal. So we're going to say if text_inputs.text field, and I'm actually going to showcase something from the previous video on strings that we talked about. So if the to upper, so I'm going to uppercase the inputs here, if that the text box and whatever's filled in there and capitalize it is equal. So whenever you're doing a comparison within C#, basically you're going to use a double equal sign if you want to test that something is equal to something else. If you just do a single equals, that's more like assigning or saying this variable is equal to a certain value. And we've been doing that previously in the code. In this particular case, we're doing a comparison or a conditional statement, so we want to use double equals. So if the text field or the text box value equals W12 by 14, then I'm going to basically come in here and I'm going to say label results.text is going to equal to yes, they match. Okay, and then basically is this true is going to equal true. Okay. Then here, if it's false, so if this returns false and they are not equal to each other, then what I'm going to do is I'm going to just say label results.text is basically going to be equal to no, they don't match. So again, just to recap, notice I'm putting a single equal sign here. And again, single equal sign is essentially assigning a value to a variable, right? So I'm telling this the label on the form and its text property to equal this specific string. Whereas up here, the double equal sign is a comparison. I'm saying, is the text box equal to W12 by 14? If they are equal to each other, then that returns true. And then we'll just say, is this true equals false? All right, so let's go ahead and run this code and see what we get. I'm going to go ahead and type in W21 by 44 here, and I'm going to say do stuff. And it says, no, they don't match. All right, I'll do W12 by 14. And then I'll say do stuff. Yes, they do match. So there you go. Basically, we have a way here of making conditional statements or conditional routing inside of our code. And this is a very common experience. You're basically saying, hey, if this is true, then I want to go this route. Or if something is equal to this, then do this type of code. If something is called column, then do this. If something is called beam, then do this. So this conditional statement operations happens pretty often. Now, here's another way of looking at all the different conditional operators. You can say not equal to. So exclamation equals is does not equal to each other. So it'd be kind of reverse of what we had set up here. Another good example is if this is equal to each other, and then you can also do and or statements. So if you do basically the ampersand here, and we say that if text inputs text to upper equals 12 by 14, and there would be another statement like, for instance, I don't know, like a string up here. So watch this. Let's actually do this. Let's say string part name as an example equals beam. And if we said basically if the part name equaled beam, basically the way this code works is that both of these statements have to be true. This profile has to equal 12 by 14 and the part name has to equal beam for this code to actually execute. If one of these statements or both of these statements is not true, then it won't work. If I need only one of these statements to be true, then you can do basically an or statement. So if this is true or if this is true, then I'm going to go ahead and execute this code. So the double pipes is basically an or, and the double ampersand here is basically an and, where both of these statements need to be true. Now, you have to really be careful. You have to really think out and test logic, because sometimes you think some things are an or statement when really they need to be an and, or you may not be able to combine everything here all in one if statement, and so sometimes you may need to do two levels or nested if statements as needed. Now, here's another example of where you can take if to a next level. So I'm going to say we're going to actually copy this, and instead of making multiple if statements, you can do this thing called Elsif. So the way this works is if you actually have multiple tests or conditions that you want to test before you get to the remaining else. Else is essentially like a leftover. It's if none of these conditions up here, none of these if statements are true above it, then essentially the else will run at the end. And again, the else is optional. So I can actually completely take this out. And if none of these statements are true, then it just won't do any else statement. So those are a couple of options. Now, what I'm going to do is here's another example of where, well, hey, maybe both these are W12 by 14, but there's a difference between a beam and a column. And so maybe I have a different set of rules here for this. And so what I'm going to do here is I'm just going to say that this is, yes, they match and equals column, whereas this equals beam. Now, the way if-else statements work is basically if this statement is true, it's going to execute this code and it's not going to look at any of these other statements. If this top if statement is false, then it's going to go to the next condition and it'll go to this else if. If this is also false, then it returns the else code at the very end as the leftovers. If this else if statement is true, then it will not go to the else statement. So that's how basically conditional statements work. It starts at the first if, then it goes to any subsequent else ifs, and then there's an else at the end. And you can have as many else ifs as you want here. Now, there's another thing called switch in C#, which is a simpler form of kind of, and an alternate form of sort of doing if and conditional statements. I'm not going to cover that here because it's kind of a different use case, but you can look that up online. Again, it's called switch. Now here we have this if, else if, and else. And essentially, let's go ahead and run the code and see how this returns. So when I say do stuff, it says no, they don't match. So I don't have a profile because I didn't type something in here. So let's do W12 by 14. And again, I did lowercase, but I did have the .to upper here in the conditional statement. So it's saying, yes, they do match, and this equals beam. And why is that true? Because the part name is called beam, and then basically it's a 12 by 14 profile. Now, what if I call this brace? Now, when I run this code, I basically should hit the else statement because none of these are both true. So like here on the if statement, the profile is not, or let's say it's even W12 by 14, but the beam is not the part name. So watch this. I'll even type in W12 by 14 and I'll say do stuff again. No, they don't match. And so the reason that's happening is because even though the first part of this statement is true for both the if and the else if statement, the part name is not equal to beam or column. It's called brace. And so that's why it's going to the else statement and saying that these do not match. So that's essentially how if and else if statements work. Now, let me show you one last piece to understand about this. If you do this here, where you say if and then you do if and you forget the whole else if piece, basically this is seen as two completely separate if statements. So this is an if statement and it will execute this code. Now there's no else here, so it's basically starting a new if statement and then running this else statement below that. So you have to really be careful with your syntax because you may be getting undesirable results if you forget to put an else if here. So remember what I said, that if you have if and then else ifs and then an else at the end, basically if this is true, it's not going to run the rest of the conditions. If this is false up here, it's going to then go to the else if. If this is true, it'll stop. If this is false, it'll continue on and finish at the else statement. All right, I'm going to show you another real life scenario that you'll probably experience in Tekla where you're going to use if statements. So I've actually pulled out the text input from the user interface, and I've assigned that to a variable here that we're going to use throughout our conditional statements. So profile equals text inputs, text field on the dialog box, text value to uppercase. Now what I'm going to do is I'm basically going to check if the profile value dot starts with. So on strings, there's this method or function here where you can look at the beginning of the string and see if it's equal to a certain value. Now, if it's equal to this or basically starts with W, it's going to return true or false. So see how when I hover over this method, it shows me that it returns a Boolean value, which is true or false. So if it does start with W, it's going to return true. If it doesn't, it'll return false. Now, basically, this if statement is saying that if this is true, then I'm going to output this. Now, let's do our second statement. If the basically profile value, instead of it being a profile, somebody types in the word brace. So starts with, I'll just say here. And now instead of starts with, let's try something else. So there's another time where sometimes you have like vertical brace or horizontal brace, and you want to do a search for contains, like it just has a partial word that you need, like the word brace. So if it contains brace and that returns true, whether it's horizontal brace or vertical brace for the full string in the text box, then we want that to return to true. Let's go ahead and run this code and see if it works. So if I don't fill in anything, no, they don't match. If I say W24 by 55, I get basically, yes, this is a wide flange. Now, here's where there's a little bit tricky something. Let's say WT 12 by 5.6. I know that's not really probably something that's real, but let's just do that. And it's saying, yes, it is a wide flange, but hey, no, this isn't a wide flange. So let's actually change the code here to handle this. So really what we need is we need an AND statement. So double ampersand, and I'll just hit return. And I'll say a profile value dot starts with, and I'm going to put in a WT here. And the trick to this is basically a shorthanded way of saying not equal to is putting an exclamation at the beginning of that statement. So if the profile value does start with a W and it does not start with WT, then we know this is wide flange and it's not a WT. So let's go ahead and test this code and make sure that that's correct. If I type in W12 by 14 here, press the button, it's a wide flange. If I do WT 5 by 12.6, and then I say do stuff, they don't match. So there we go. There's a good example of a real life use case that you might have to search. Now let me just say vertical brace here. We'll try that option, and I'll say do stuff, and it does say yes contains the word brace. So this is expanding on that previous lesson where there are lots of great functions or methods that are on strings that you can use to parse and make testing conditions to see whether or not a profile or a certain part name matches what you're trying to do in the model, and then you execute that code one way or another. I do this all the time. I'm looking for certain profile types, or I'm looking for beams versus columns versus braces, and doing different code between those.